Yes.
Hmm. Okay. So I was saying that we're talking about the group 2 elements. We covered the natural occurrences that they have. We also studied about the other name that they're given, alkaline earth metals, right? Then we spoke about trends in the atomic radius and what makes them different from, or what, and we stated that in group 2, right, when I'm looking at the periodic table, right, we stated that we have is it beryllium which is on top.
Yes.
We stated that it is not called an alkaline earth metal because of its size and its high charge density. It's like it's totally different from the rest of the elements there.
Very good.
And
Okay, so very good. Can you hear me?
yes, I can.
So now today we are doing flame test. Okay, what is flame test? As we have already covered the colors like beryllium, magnesium, due to their small size, they produce no flame colors. Calcium form brick red, strontium form crimson red, and barium forms apple green color. So how it occurs? The salts of alkaline earth metals, except that of beryllium and magnesium, they produce characteristic color to the flame. Why? Due to easy excitation of electrons. Excitation means to traveling of the electron from lower energy state. This is your energy 1. This is your energy 2. So from lower energy state to higher energy state. This is known as my excitation. So due to easy excitation of electrons to higher energy levels, they produce characteristic color to the flame. Why beryllium and magnesium do not give any color to the flame? Because of their small size. They bind their electrons very strongly. So they possess high excitation energy and they are not excited by the energy of the flame to the higher energy state because their electrons are binded very strongly. So that's why no color is produced to the flame in case of beryllium and magnesium. Is it clear? No?
It is clear.
Write it down. So you can see here that beryllium and magnesium, they do not impart any color. Calcium, it is intense white flame with a tinge of red at the end. Strontium, it is a red tang, and barium is a pale green flame.
Hmm.
Flame. So please answer these questions. How many electrons do group 2 elements have in their s orbital of valence shell?
I can't see.
Sorry.
Okay. They have how many electrons do group 2 elements have in their s orbital of the valence shell? They have 2.
Yes. What is the color of barium?
Color of barium is in the flame.
Mm.
It's, oh no, wait. Wait, what's on top? Wait. Flame. Okay. Barium. So we say it is barium, calcium, and what? Whichever flame.
The color of
Is
barium in the flame.
we say it is calcium. What?
I'm asking for barium, not calcium.
Oh, okay. You're asking for barium. It's from those colors. It's apple green.
Yes. The most electropositive amongst the alkaline earth metal is?
The most what?
Read the question.
So we said electronegativity as you go down the group, right?
Electropositivity.
Or electropositivity increases as we go down the group, right?
Hmm.
So the most electronegative is
Positive.
barium. Electropositive, yeah, is
Yes,
barium.
yes, very good. Next, we are going to learn about the ionization energy. So, what is ionization energy? The amount of energy which is required to remove the loosely bound electron from an isolated gaseous atom. We take the gaseous atom because we want to make it free from any other considerations, right? So, energy which is required to remove an electron from the to remove the loosely bound electron from isolated gaseous atom. So, which have higher ionization energy, alkaline earth metals or alkali metals? So, alkaline earth metals have higher ionization energy. Why? Because their atomic size decreases. Ionization energy is inversely proportional to atomic radius. We know that ionization energy decreases down the group. Why? Because atomic size increases down the group and it outweighs the increasing nuclear charge. What is nuclear charge? The charge on the nucleus. It is called your nuclear charge, the positive charge on the nucleus. Is it clear?
Okay.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
So, here it is written that alkaline earth metals, they possess smaller size and greater nuclear charge, right? They have greater nuclear charge, that means greater number of protons than the alkali metals. So the electrons are more tightly held and hence the first ionization enthalpy is greater than that of the alkali metals. Second ionization enthalpy of the second group elements, it is less than the second ionization enthalpy of the first group elements. What is second ionization enthalpy? The energy required to remove the second electron after removing the first electron. So it is less for the alkaline earth metal as compared to the alkali metals. So this we will get to know after writing the electronic configuration. Non-radioactive metal of group 2 having least first ionization enthalpy is barium. So here the order reverses actually somewhat, that it is radioactive. Which is radioactive? Radium. It is radioactive. So non-radioactive metal which is having the least ionization enthalpy, it is barium. Radium is radioactive. So these are some of the uses, like beryllium. It is used in your spacecraft, aircraft, missiles, and X-rays. Magnesium, it is light. That's why it is used in aeroplanes, missiles, flares, bombs, car engines, medicines, computers. Calcium, it helps in building strong bones and teeth. It is used in milk and it is used to make plaster. Strontium is also used in flares and to create a crimson color. So can you answer this question?
Calcium.
Yes, it is calcium. Which alkaline metal is essential for maintaining healthy bones and teeth? It is calcium. Uses of radium, it is used in treating cancer. Uses of barium, it is used in medical applications, glass making, rat poison, and making rubber. So please answer this question.
Two.
Yes. Okay. So this all we have discussed. Now we are going to learn about the chemical properties of group 2 elements. So like alkali metal ions, hydration enthalpies of alkaline earth metal ions It decreases with increase in ionic size down the group. So it is beryllium 2 plus, its hydration energy increases as compared to magnesium 2 plus. So the hydration enthalpies of alkaline earth metal ions, they are larger as compared to alkali metal ions. They are most extensively hydrated. For example, MgCl exists as MgCl2.6H2O. Calcium chloride exists as CaCl2.6H2O. Whereas alkali metal like sodium, potassium, they do not form such hydrates. So always remember that hydration enthalpy, it decreases with increasing the size of your alkaline earth metals. So barium size increases, so its hydration enthalpy decreases. And if we compare it with the alkali metals, then alkaline earth metals have larger hydration enthalpy as compared to alkali metals. Write it down. And can you try to answer this question, that why alkaline earth metals have higher hydration enthalpy as compared to alkali metals?
Yeah.
Because alkaline earth metal ions have smaller sizes and high charge densities. So these are your reasons. High charge density.
Yes.
So how they react with the alkali, with the acids? So this M, it is your alkaline earth metal. So when it reacts with sulfuric acid, it gives you MsO4 plus H2. Okay, M is your beryllium, magnesium, calcium, and etc. When it reacts with hydrochloric acid, we have MCl2 plus H2. Reactivity of alkaline earth metals increases on moving down the group. So the reactivity of calcium, it is more than magnesium. This could be related to the increase in electropositive character. So beryllium reacts very slowly, magnesium reacts very rapidly, while calcium, strontium and barium react explosively. That means giving explosion, because the activity of alkaline earth metal increases down the group. So last three elements, they react with an explosion. Magnesium reacts very rapidly, but beryllium reacts very slowly. Is it clear?
Yes.
Okay. The next properties are reducing nature of the alkaline earth metals. So what is reducing nature? As we know that alkaline earth metals, they have 2 electrons outside the noble gas configuration, right? That means 2 valence electrons alkaline earth metals have. So due to their large size and low ionization enthalpy, they can easily lose outermost electrons and they can undergo oxidation. This reaction is metal. It is giving me M2 plus. Okay, this plus is coming here, plus 2 electron. So it undergoes oxidation. Oxidation means loss of electrons easily. So which undergoes oxidation easily, that means they are strong reducing agents. So are they strong reducing agents or strong oxidizing agents? So you have to write that they are strong reducing agents. They reduce others, but itself they get oxidized by the loss of electrons. Okay. The next reaction is reaction of oxides with dilute acids. So the basic oxides of group 2 metals can be neutralized by acid, dilute acid. As you know that basic oxide, when it reacts with dilute acid, this is a word equation, gives us salt and water. That means acid plus base gives you salt and water. This is a neutralization reaction. So this is a metal oxide which is basic, right? HCl is acidic, so it reacts to give us salts and water. A similar reaction occurs when excess dilute sulfuric acid. This is also an acid. Okay, magnesium oxide is a base. So when acid and base reacts together, it gives us salt and water. But here a sulfate solution is formed and here a chloride solution is formed. Okay. So this is the reaction of oxide with dilute acids. So this is the reactions with oxygen, that the group 2 metals burn in air and burn more rapidly in oxygen gas. For example, magnesium, it burns in oxygen to form magnesium oxide. This is a white color solid oxide. Okay, and it burns with a bright white flame when it is ignited in the Bunsen flame. Magnesium oxide, it is your basic in character. The group 2 metals get more reactive with oxygen going down the group. So as you move down the group, its reaction with oxygen is more reactive. Larger atoms, they lose their outer 2 electrons more readily than the smaller atoms in the group. Barium metal, it is so highly reactive that it must be stored under oil to keep it out of contact with air. So this is an important point, that as I told you, reactivity increases down the group. So barium metal it is very reactive, that it must be stored under oil so that it cannot react with air. So write down an important point.